let us discuss the topic integral calculus. Now, when we are discussing the topic of integral calculus, the first thing we need to discuss is line integrals. Okay, so line integral is a expression of the from integration a to b a dot dl vector. Okay, so if we draw this in a graph, it will look like this, that there is a y axis, z axis, x axis, and we have a line in the format of this, which is one point is called A, another point is called B, and there will be very little part, that means a small part of this is called DL. Small part of this path is called DL, and this line is made of the infinite number of this small part dl, and the lower limit of the integration is a and the upper limit of the integration is b. So this is how a line integral is represented by a line where many small part like dl. The line is made up of very small part, infinite number of small part dl. The next topic is surface integral. Now the surface integral is written in the form of integration into surface integration of s and a dot dA, and it is represented graphically like a surface where the dA direction of dA vector is always at the normal to the surface. Again, a example of this line integral is work done. Example of this line integral is work done, where we write work done by f vector dot dl vector, line integration of f vector dot dl vector. Now next topic to discuss is volume integral. Now the volume integral is in the form of v and t d tau, where d tau is a very infinitely small volume element which can be represented by dx dy dz, product of dx dy dz. So if we write a volume integration, now here t is a scalar function. Now if we take a vector function and take the volume integration of that function, we get ax d tau plus ay d tau plus az d tau. plus az d tau. Given, okay, so wait a minute, no, this is not correct. Let's erase this, get the correct one here. So now let's do this step by step. If a vector d tau, we can write integration. A vector can be written as ax I cap plus ay j cap plus az k cap, and the d tau is d tau. So we can write integration I cap integration ax d tau plus j cap integration ay d tau plus k cap integration az d tau. Next we will discuss the fundamental theorem of calculus. So let's discuss the fundamental theorem of calculus. So the fundamental theorem of calculus is integration a to b df dx dx equal to f of b minus f of a. Now if we take the df dx as a function of fx dx, then we can write a to b equal to f of b minus f of a, where এখানে একটা where আছে f of x equal to df dx. Next we need to discuss is fundamental theorem of gradient. Fundamental theorem of gradient, which is dv equal to grad v into dl vector. So this is a normal gradient, and if we take a look at the fundamental theorem of the gradient, that will be integration a to b grad v dot dl vector equal to v of b minus v of a. Next topic that we need to discuss is fundamental theorem of divergences. Fundamental theorem of divergences. Fundamental theorem of divergences. If we take integration of v del dot a d tau, then that will give us surface integration of a dot dA. This is also called Gauss divergence theorem. This is also called Gauss divergence theorem. Next, we will discuss the theorem fundamental theorem for curls, fundamental theorem for curls, and that will be surface integration del cross A dot dA vector equal to close integration P A dot dl vector. So here this is also known as Stokes theorem. This is also known as Stokes theorem. So this is some basic theorem and some basic rules for vector integration.